Hello students, welcome to Exam List. In this lecture, we'll talk about particles, fields and continuity equation. So when you have a particle with you, how do you define the motion of particle? You define the motion of particle from Newton's equation that says that force is equals to mass into acceleration. Okay? But when you are considering fluid, okay, so consider this is a fluid moving through. The fluid contains a lot of particles. Okay, all these particles, or you can say molecules, are moving with a particular velocity, and as a result of which there is a overall motion which we call as the fluid velocity. Now to understand the motion of this fluid velocity, if you are going to apply Newton's law F is equals to ma, then you have to apply F equals to ma to each particle that makes up the fluid. Now this is very difficult. If this fluid contains say about 10 to the power 20 particles, then it is difficult to solve 10 to the power 20 such equations and tell how the fluid is moving. So instead of doing this, what we do is we use the idea of fields. Okay, what do you mean by field? So instead of studying the fluid by looking at what happens at the microscopic level, we look and understand the fluid by looking at from an overall view. For example, how about density? We look at density of the fluid and we talk about something related to this. Okay, what is that something? Okay, so our first example of finding something will be a continuity equation. Okay, so let's try to understand continuity equation. So consider you have a pipe which has a small area here and it has a big area here. Okay, so let the area here be A1 and let the area here be A2. Now along through this pipe, consider fluid is moving. Okay, so this is the fluid, my yellow color, and the fluid is moving through this pipe. Now something interesting happens when the fluid is moving through this pipe. First thing is, you know that mass of the fluid which is entering from the left part of the pipe or the left opening must be equal to the mass leaving the right opening. If this does not happen, then there will be accumulation of some mass inside the pipe and it will cause the pipe to burst. We don't want that. Okay, so usually what happens, somehow the fluid maintains the incoming and outgoing mass. So how does it maintains it? Let's see. So consider in a small time dt, what will be the distance moved? So in small time dt, if the velocity at this part of the fluid, say the velocity at the left part is v1, then in small time dt, the distance moved is v1 into dt. Okay, so this is the distance moved. Then what is the volume? So in dt time, how much volume of liquid entered the pipe? So it will be A1, because you know that area into V1 dt will give us volume. V1 dt gives us the length below and A1 is the area, so it will give us volume. Now if you multiply density with volume, you get what? You get the amount of mass entering this pipe through the left hand side. Let's do the same on the right hand side. So on the right hand side, in a small time dt, this particular length will be defined by velocity v2 into dt. So how much of mass is leaving from the right hand side? So let me write it as m out. Okay, and this is equal to, so what is volume? First write the volume. It is A2 into V2 dt. See, time is same. Okay, because we are considering the mass in and mass out for a small time dt, and you need to multiply rho to get the mass. Now all of you know that if there is no accumulation of mass inside the pipe, or else it will cause the bursting of pipe, we need the mass in and the mass out to be same. It means rho V1 A1 dt, that is the mass in, must be equal to rho V2 A2 dt. Now interestingly, rho, which describes the density of the fluid, is same at the location, at the left hand location, and the rho is same at the right hand location. It means in this case our rho is constant. That is, the density of our fluid is constant. It means our rho is not a function of time because it does not change with time, and it is not a function of space because the rho is same at the left hand location and the right hand location. So I can say that rho is not a function of t, x, y, and z. Okay, it means I'm talking about an incompressible fluid. Anyways, so what happens to this equation? Rho gets cancelled both sides, dt gets cancelled both sides, and you're left with this equation that says v1 into a1 equals v2 into a2. It says that if the area A2 is very big, then V2 is going to be smaller. And if the area A1 is smaller, then V1 has to be very high. Okay, it means that the velocity with which the liquid is entering the left hand portion is not same as the velocity with which it is exiting the right hand mouth. Okay, this is the continuity equation, because only when A1 into V1 is equals to A2 into V2 is satisfied in both cases, then it means that mass is not getting stuck inside the pipe. Now let's try to understand. So if the left hand mass is left hand area is 10 centimeter square, and say the right hand area is 20 centimeter square. Okay, and say my liquid entered with 2 meter per second volume in the left hand side. It means that to have this thing equal, my liquid or my fluid on the right hand side must come out with a velocity which is equal to 1 meter per second, because only then I'll get 20 both sides. You see that when the liquid went from the mouth of the pipe, for which the area is less, and when it came out of the mouth of the pipe, for which the area is high, the velocity of the liquid decreased. So continuity equation tells that this thing is going to happen. Okay, now this is a very simple way to write continuity equation. This is simple because our rho was constant. But if I ask you what is going to be the continuity equation if rho is not constant, then what we are going to do, we'll look at in the next lecture.